Hello, everyone. Good evening. Nice to have you here in our meetup session from the Azure Zurich user group. Today, another great session we have planned in our AKS series with guest speaker Radoslav Gatev today. So, just some few words for the introduction. So, who we are, the Azure Zurich user group, and that's Manuel Meyer, the, let's say, a founder of the group, and me and Carl supporting him in hosting the meetup. And as I said, we have this session is part of on our series for some insights on what is AKS and where can it help you, and what does all this universe include. So already last year we started in December with the first series with an introduction to Kubernetes itself by our guest speaker Jonas Felix. For myself, there was the next part in January for the AKS service itself. So the other Azure edition in the way for Kubernetes. And then we continued the series with a great example from the real world from Mark Merzenir, where he told us about problems and interesting insights he had from migration in Azure App Services to AKS. Nico Meisenzahl then in March told something about let's say more insights and some advanced integration to other services, which is possible with AKS. And the original planned series number 5 for advanced network and security topics by Mohamed Nofal, we postponed because we are just Mohamed will wait for some events where some updates and news will be posted, so we'll include in these in his session. So just to make it even better, so we postponed it in June. And now we have originally planned number 6, but scheduled as before the session of Radoslav, where he will tell us some great stuff about what is Dapr and how it can help in this microservice context. So all of these sessions are you can find in our meetup group, and we published the slide decks, and the stream is still available on the speaker deck page. You can find all information on our meetup group. So if you're interested in these already past parts, then feel free to watch the slide decks or the streams. Everything is still available. So I think enough words for introduction of this series. And with that, I will hand over the stage to Radoslav to start the great session.
Thomas, I hope you can hear me now.
Yeah, great.
Okay.
I put your deck.
So do you see the slides?
Yeah, great.
Okay, that's very nice. So hello, everyone. And first of all, I would like to thank Thomas and Manu for inviting me to speak here. I would like to visit Zurich someday. So maybe for the next event that I'm going to speak in Switzerland, I may come and make it in-person event. And I would really like to return to in-person events because I'm really tired of all those live events and hybrid events and whatever. So my name is Radoslav Gatev, and today we're going to talk about how to build better distributed applications with Dapr. So a few things about me at first. So I'm a solution architect and a consultant. I have a very diverse background, so very solid years of programming, pretty much with .NET Core, also some data-related projects in big data technologies, and also some Internet of Things. And above all, I love Azure, so I try to do as much as possible in Azure. And I'm really helping different companies around the world to build better applications in the cloud, or fix their existing ones, or migrate from other clouds, or whatever they want. um, so I'm also a Microsoft Azure MVP. I'm one of the organizers of some of the major events in Bulgaria. And I also try to write blog posts and be an active community contributor and help the community. And you can find me here. This is my blog, gatevnotes.com. And you can find me also on LinkedIn or on Twitter if you want to. Just mention that you have watched that stream. And I happen to have a book on the topic. It's called Introducing Distributed Application Runtime, Dapr. So when the pandemic began, there was an opportunity coming from Apress. So at that time, I was really excited about Dapr because it provides a very good way to build distributed applications. So I decided to write a book on Dapr, because what else should I do during the pandemic? I mean, and I was lucky to pass that book to the first readers, who were Yaron Schneider, who is one of the co-founders of Dapr, and Mark Rusinovich, the Azure CTO. So Yaron wrote the foreword of the book, and Mark Rusinovich provided a praise quote for the back cover of the book. I'm really honored to have such a first readers. Anyway, I'm not telling you to buy that book right now. I mean, you may be, you are a person who likes reading the documentation and learn from there, as I do, or you may prefer watching videos or live streams. So that's kind of advertisement, but it's not. I mean, you don't have to buy that book. You can find everything online. So let's take a step back and figure out what is the current state of enterprise developers. So those guys should figure out a way to deploy large-scale applications, and at the same time think about things like flexibility, cost, efficiency. Besides that, those applications themselves should be developed in a resilient manner. They should be scalable. And the microservices approach is pretty popular, but with it brings some complexity. And essentially what developers want to do is to focus on building the applications and not learning about the infrastructure, because you cannot really be very deep at everything. You cannot know Kubernetes and virtual machines and at the same time write perfect applications and at the same time deal with the data. It's very hard to do. You have to track a lot of things. And that's why developers kind of prefer nowadays to have a serverless platform where you can write simple code and just hand it over to the platform itself, and don't care about the infrastructure that is sitting behind and executing your code. And if you are building a very complex and a distributed application, it will most likely include a couple of languages, a couple of frameworks, and all those things added together are making the state of enterprise application development really, really difficult. So let's see an example of the microservices architecture. Here is an example e-commerce application. The users are connecting via internet, obviously, to the front end, which in its turn connects to the cart service. The cart service itself discusses things with the payment service. We have an inventory service, of course. It seems to have its own state. We have a checkout service, and it uses an external state management component. And we have a shipping service, because those things should be delivered someday to our customers. And we have some queue here. So essentially, if this is a really big project, most likely some of those or groups of those microservices will be built by separate teams. So some team will be the expert of inventory and the owner, whereas other teams will own the shipping service. But this whole thing should work as a whole, right? So for state management, we should figure out what is the proper state management component and to integrate its SDKs in the checkout service. So you can sense the difficult picture here. So what is really holding back the microservices development? There are three major things, basically. So the tools that we are using for building microservices are pretty limited. Most of the times they come in a very opinionated way, so they try to force you to use their own peculiarities and their own specifics. But basically, those tools are good in one platform, but you cannot really transform them to another platform if you want. So let's talk about service meshes, for example. They handle traffic, they handle security, but they don't provide too much about development, right? They're more closer to the infrastructure stack. And the runtimes have limited language support and very tightly controlled feature set. It may do one thing, a single thing, and it may do it better, but you lose the flexibility here. So to our help comes Dapr. Dapr stands for Distributed Application Runtime. And the official description of Dapr is that it is a portable, event-driven runtime for building distributed applications across cloud and edge. So this is pretty overloaded thing, right? We will see what this means later on in the presentation. But basically, for now, just assume that Dapr is something that provides a set of good practices packaged in a very good way for you to use as a developer. And you can see that it's used by many companies like Bosch, Zeiss, Alibaba Cloud, and many others. And in terms of community, the things are going to look interesting here, because Dapr was accepted in CNCF as an incubating project. It has a lot of stars, like 18,000. It has about 2,000 contributors in GitHub, and a lot of the functionality comes actually from the community itself. So if you happen to develop some component for Dapr, you can contribute it back to the repository. You can see the Docker hubs, the monthly pulls are over 1 million, and we have some traction on the docs as well. You can see the organizations that are contributing to Dapr, which are Microsoft, obviously, it started from here, VMware, Intel, and a lot of other big companies. But anyway, so let's talk about the goals of this Dapr project. And it's very well-maintained project. Everything is open source, everything is on GitHub, so you can track pretty much everything that's happening. So what are the goals or the main ideas that this runtime tries to establish? So first of all, as I said, it provides best practices building blocks, which are really the patterns that you can use when you are a developer. We'll see about that. So those patterns come with a very consistent and a portable model for exposing APIs, which means that every building block has an API. And those building blocks are very extensible, so you can swap components, you can swap the functionality of the building block, or rather the backend services, which are basically taking care of the operations of this building block. And Dapr also supports every language, every framework that you can think of. It adopts standards like cloud events or open telemetry, and it is built for with platform agnostic mind, right? You can host this in the cloud, or you can host it in the edge pretty much wherever you like. And it's community driven, so it will stay vendor neutral. So what about the Dapr APIs? Let me enable the pointer. So here are all the Dapr building blocks that it provides. We can see service-to-service invocation, state management if you want to persist state. We have publish and subscribe, resource bindings and triggers, actors, observability, secrets, configuration, and those are the building blocks that we are going to see later. But first of all, let's look at how the things are working at a high level. So you pick and choose your application framework. You may pick some framework in Node.js. You can pick ASP.NET Core or .NET, whatever, just to name a few. And it has to support HTTP and gRPC, and it's hardly possible to find a language that doesn't implement the HTTP stack, right? So whatever implements HTTP can talk to Dapr, which is pretty much anything. And at the same time, Dapr provides also the gRPC API, which you can use if you are a fan of gRPC, or if it was one of your decisions that you took. And you can host this whole infrastructure anywhere you would like. So any public cloud, any virtual or any physical machine, or Kubernetes, it supports them. So what is the main architecture pattern that Dapr uses? Well, it's the Sidecar model, and it's a design pattern that is pretty popular when we have containers. Because on the left side, we can see that we have some application called MyApp. And this is our application code that we have built using our framework of choice and programming language of choice. And we have a sidecar. And this happens to be a sidecar. So the generic design pattern says that the sidecar is something that provides added value, added functionality on top of your code. So you don't have to rebuild your code in order to utilize the sidecar. It's there and it's waiting for you. And it is also a model for extending an application that you don't have the source code of. So you can really stand up a sidecar, and this will complement your application. But anyway, in the Dapr case, this is the Dapr sidecar that provides all the building blocks that hosts them. And each and every application has a sidecar. So the sidecar is a representative of your application. And your application, as I mentioned, communicates over HTTP and gRPC to Dapr. So if you want to invoke another service of ours, we can use just this localhost 35,000. This is configurable. And we can say that we want to utilize the invoke building block of Dapr. And here the cart is really the application name that we want to call. And its method is new order. So our application, my application, will call the cart application in its method new order. And Dapr will return the result for us, of course. So in the example of state, if you want to get a state from a state store, we just issue another GET request to the state building block. If you want to publish an event, if we are using the publish and subscribe building block, we use just this API, publish. And if we want to get a secret, we just swap this with secret, and this is the name of the secret store. Anyway, we will look into details after that. So here you can see a more broad picture of sort of an entire architecture. So on the left side, we have my application, which is the same as the previous, right? But we have also another applications or services that are also using Dapr. And the sidecars of each 3 applications or services are connected. They are the same network. So the fact that those sidecars are connected makes it really easy to provide added value here, because you can just plug in the state management building block, you can use secret management. Observability is really easy to be done in this scenario. And really, behind those components, behind those Dapr building blocks, there are components that are providing the specific functionality. So if you are a developer, you probably use interfaces, so or abstract classes. So the building block is really the abstract class. It provides some functionality, but it also leaves it open for any components to substitute your desired functionality. So those components are really pluggable. If you happen to use a state store, you can start with DynamoDB and then switch to Cosmos DB with just a single configuration file change, because those components are defined as YAML files. And this is something pretty typical if you are using Kubernetes for hosting those entire applications. So there are over 1097 components available, and this number of components is really growing. You can find all of them and their source code on GitHub, on the components contrib repo. So let's play a little bit with the example of pluggable components. Here we happen to use the HashiCorp Vault for secret management, and we are on premises really. We use RabbitMQ for publish and subscribe, and we use Redis. The different services are using those differently. But if we want to move to the cloud, that's very easy, because we are just using the building block, right? So in AWS, the secret store can be handled by the key management service. For publish and subscribe, we can use simple notification service, and instead of Cosmos DB, we can use, for example, DynamoDB. And if we go to Microsoft Azure, sorry, the previous example was on premises, but here we are switching to Azure Key Vault, Azure Service Bus, and Azure Cosmos DB. And again, we don't have to change anything in our code. We just have to change the configuration of those components, which really the operations guys can do without you redeploying and figuring out the configuration. So let's take a look at each and every Dapr building block. We will see them one by one. So here is the service invocation. We kind of scratched the service of that one. So we have a checkout application that wants to create orders. So that checkout application, whenever a customer has paid his order, well, his shopping cart, on the background, we should create a new order for them. So we invoke the invoke API, and this application is named order processor. So here it goes, and its method is orders. So what will happen after we call the Dapr sidecar? This is, by the way, the port of the Dapr sidecar that the checkout application has. So the Dapr sidecar will invoke or will call the name resolution component in order to figure out what the IP of the other sidecar that we want to call is. So currently, the supported components for service discovery are MDNS, Kubernetes DNS, the built-in one with services, and HashiCorp console. So those are the three. On my local machine, I can use MDNS, whereas in Kubernetes, So once we know the IP address of the other sidecar, we can simply make a query to it. And the query will use mutual TLS. So mutual TLS is the way to encrypt the traffic from both sides, between both Dapr sidecars in this case. And the certificate can be rotated every 24 hours or even every hour. It's configurable. So once the respective Dapr sidecar receives our request, it will then call the order application, which is basically some application code that was that is expecting basically that has an endpoint called orders, and it will receive the same post request with the same payload. And then the Dapr sidecar system will make sure that it will basically transfer the payload all the way back to the calling service. So that's basically the service invocation. Is the building block for calling whatever whatever services you have. And then we have a demo for that. So let me switch to Visual Studio Code, and I will show you a demo with a Node.js based application, which is pretty simple. I got that from the official Dapr getting started or quick starts or examples. So this is a Node.js application. It listens on port 3000, and it has an endpoint. And I really hope that you can see that font. For me, it looks fine. So whenever a new order comes in, this service will just log to the console and return the status and the order ID. So let's see how this thing works. So I have prepared a small script file here. It's not really PowerShell. So first of all, of course, you have to install Dapr. And I have Dapr on my machine. So if I open the terminal, or even I have terminal, but anyway, if I type Dapr-H for help, it will display that. And that's a nice image, right? So the local installation really is pretty easy. You just have to install the Dapr CLI, and you have to invoke Dapr in it like that, and it will set the things up for you. So if you want to run that application locally, since it is a Node.js application, we have to have the Node.js installed, and we also have to install the npm packages that this application depends on. So I've done that, but let's really run the Dapr application itself. So the Dapr CLI comes in handy here because it has a command that is run, and it allows you to specify the application ID. So that's the way our application will be named. Or if other application wants to call our application, it has to provide the name of that application. So this is the place where we supply that information. This is the application port where our application listens it. And this is the Dapr sidecar port. So whenever we run that command, it will start a new Dapr sidecar, and it will also start our application with that command here, node app.js. So let's run that. And you can see a bunch of logs appear here. So it says the components are loaded, the gRP proxy is enabled, API for gRPC started, and it's, by the way, listening on port 54818. So if you want to call the gRPC server or the gRPC API of Dapr, we can use that port. But we will just use the HTTP APIs of Dapr. So if you want to invoke a Dapr application, we really have a lot of options. One of them is to use a pure HTTP query to the Dapr sidecar, to any Dapr sidecar. We can also use a Dapr SDK of some language. So if you happen to be implementing a Dapr application in C#, maybe you will benefit from integrating the Dapr SDK for .NET, for example, because it will be easier. but it's your choice. I mean, you can use the raw HTTP stack. So here in that example, we are just calling the Dapr CLI. We are using it to call our sidecar, and we specify that we want to call the node application and its method new order, and we specify this kind of data as a payload. So let me open another terminal, because this one is kind of blocked by my current Dapr run command, and I will invoke that Dapr invoke method here, and you can see it says got a new order ID 41. So yeah, that was the demo. I hope you understood the primary concepts of service invocation. But anyway, our DAP got invoked, and currently we can invoke it however many times we want to do. So we can call it again, and it will return again. That's because we have another terminal which is hosting the Dapr runtime currently, and our application as well. And the way to stop that is to use the Dapr CLI stop if we are running from another terminal. But here we can just kill the terminal, and it will be, the application will be killed. So that was all about the service invocation building block. Okay, so let's go to the next one. So state management. All applications have state. Let me clear the. Okay, so all applications, or most of them, use some kind of a state. And if you want to use that to integrate that state and persist it externally, we may use something like Redis cache, for example. So Dapr has a state management building block, obviously, for that. And we have to just configure the Redis cache component here in order to work with that Redis cache. And our application just has to call, has to issue a post query to the state endpoint. And because our state store is called, or the component is called order store, we can address it via the query to the Dapr sidecar. And with that query, we specify some payload, which has a key that happens to be order 1 and value my order. And you can see that on the left-hand side, it will get persisted as my app order. The field will be data, and the value will be my order. So the key gets something like a prefix, and that's the name of the application that tries to persist that state. So we have a distinction or isolation between those applications thanks to that prefix. So for state management, really we can swap those components, and we, instead of using Redis cache, we can use AWS DynamoDB, and we just have to change the component. And that's it. So let's see how the component looks like in YAML format. So this is the YAML component that you have to have in place in order to integrate with Redis, for example. And this component, this Redis cache stored in Dapr, is called order store. And as a metadata here, you can specify the connection strings and all connection information, or rather all information that the component expects you to provide. But in this case, we just provide the Redis host. Here is our Redis on port 6379, and we specify the Redis password. Of course, no passwords are good in plain text, so Dapr supports a secret reference, and it can use plenty of secret stores to store those secrets. So on the left-hand side, you can see the state API, but I will really leave that to you for you to explore in the documentation, because it's really well documented. But the basic things that you can do with the state API are that you can save state, you can retrieve it later on, or you can delete it, you can get it in bulk, or you can execute transactions. So I just described how it looks when we use the Redis cache, right? But this is the same type of component, but for Cosmos DB. And here, instead of specifying the communication, the information to communicate with Redis, we specify the relevant information for establishing a connection to to Cosmos DB. So we provide a master key, name of the database, and the collection. And some advanced features of the state component are that it supports strong consistency or eventual consistency, and those are really configurable. And it uses optimistic concurrency control using key tags. I just want to go through them very briefly because we can spend maybe half an hour to an hour talking about all those specifics here. So it supports transaction. So it allows you to have shared state. You can configure the time to live in the respective state store. It really depends on what the state store supports, of course. And you can also encrypt the whatever you store in the state store. You can encrypt it before sending it. I mean, on the Dapr side of things, you can encrypt it. Okay, so let's see a demo of state management. But first of all, let me walk you through the architecture that of the applications that I'm going to show you. So it will be a distributed calculator, which uses a set of microservices to implement its operations. So, for example, we have a Go application that implements the other. We have a C# application that implements the subtractor. And we have also a Python application that is for the multiplier. And the divider is in Node.js. And the way that I'm going to host that application is in Kubernetes, because kind of the downside for me of running Dapr locally is that you have you need to have the whole application stack installed in order to be able to run that application. Whereas in Kubernetes, everything comes as an image, so you just pull it and instantiate it, and that's it. So it's kind of simple. It depends on the use case as well. For the front end, we have a React application that basically communicates with all those all those services. And also the React front end uses a state management component to persist the state of the number that we see on the screen. Okay, so let's switch to the demo then. So where is my cursor? Here it is. So let me show you briefly the applications. I won't to dive too much into that. But as you can see, the app method is an application, a method implemented in Go. It has a main function, and it also accepts two operands, and it adds one to the other and returns the result. So for C#, what do we have? Subtract controller, and it takes two operands. Essentially, it's the same interface, but this time the C# application will just subtract one of the numbers from the other, and it goes like that for the other two applications as well. So how do we run that into Kubernetes? So first of all, we need to have a Kubernetes cluster somewhere, and we have to establish a context to it. And once we do that, if we have the Dapr CLI, it's the same Dapr CLI that we just used for the previous demo, But now we can say Dapr init-k, and K stands for, as you may imagine, for Kubernetes. So it will go and basically install the respective Helm chart for Dapr. That is what is going to happen in the background. But really, for you, it's a simple command, and once you have executed it, it will stand up a couple of pods for you. Obviously, as a prerequisite, you have to install Redis, and I've already done all those things. And you can do so by installing the Redis Helm chart for Bitnami. And we can start deploying the applications now. Well, the microservices application rather. So let me show you how it looks like, how it is defined. So let's, for example, open the .NET Subtractor application. So it's a regular Kubernetes manifest file, manifest YAML, and it really says that the name is a Substract app. It has some label, and here is the spec of it. So the template goes like this. You have some annotations that is for Dapr, because Dapr parses those, and whenever you specify the Dapr annotation, like Dapr enabled, the respective pod inside Kubernetes that is coming from the Dapr system will inject a Dapr sidecar besides your container, which is defined here. So our container is coming from the official quick samples, samples repository of Dapr, and it is called the distributed calculator C#, and we are getting the latest version of it. And the container port is 80. But as I said, besides that container, the Dapr system will automatically will deploy another container besides that one in the pod. What else do we have? So the other 4 applications are defined like that. For Redis, we have the Redis state store. It's essentially the same as the one that we saw on the slides a little bit earlier. And we are utilizing the Kubernetes secret store here for obtaining the secret, the Redis password. And we have also an application configuration, which configures things that are valid for all Dapr applications. So let's run that and see how it goes. So where is my steps file? Okay. So we have to navigate to the deploy directory and then apply all those manifests. But as you can see, all of those are unchanged. And here is the way that we check the status. And we have to port forward that service. So now it basically makes the service accessible for me on port 8000. And here it is our calculator. So 2 plus 3 equals 5. And then if I open another tab, it will utilize the state store to get that number. And we can start from there. So minus 5 minus 1 is 4, and we can continue on and on. So that was the demo. It really features how to communicate with multiple applications in Kubernetes or even locally if you want, and how to persist state at the same time. Okay, that was the demo. Let's get back to the slides. Okay, so publish and subscribe. Publish and subscribe is really a popular pattern. If on the one side you have a producer, and on the other side you have consumers, and all of those, as you might expect, have their sidecars, and the sidecars are really communicating with the message broker or whatever it's supported. You put it as a component here, right? So my application or your application makes a call to the publish endpoint of Dapr, and it targets this order topic, and then all the consumers will get notified that there is a new message here. There is a new event for on their order endpoints, and yep, as you can see, they are running on different IPs, and here we are calling the Dapr sidecar. Okay, so we can swap those components with different. We can swap that Redis cache with different technologies like Azure Service Bus or SNS or even the MQTT protocol. It doesn't really matter. And we have a publish and subscribe demo. Let me show that one. Now, that demo is yet another Node.js application, which is still simple. So it still listens on port 3000. And the thing that I forgot to tell you is that applications have really two ways to subscribe to events in Dapr, and one of the approaches is the programmatic subscription. So every Dapr application that wants to subscribe to anything in Dapr can expose an endpoint called Dapr/subscribe, and this endpoint will get called by the Dapr runtime at the time it starts in order to interrogate your app whether it utilizes the programmatic subscription. So if your application returns any result here, Dapr will know how to handle the result. So this result is basically saying that the pub/sub name that we want to subscribe to is called pub/sub, and the topic is inventory, and the route that we want to follow in our application is called products. Or if we want to utilize the routing rules, which is a new feature of Dapr that is a long-awaited feature in Dapr, by the way. So it allows you to specify routing rules for the incoming events. So here you can see the logic described as in the JSON format. So it subscribes for the pub/sub name, the topic is called inventory, and the event type is widget. So Dapr supports the cloud events standard or specification, and they have a type. So if this type happens to be widget type, we just say that our application needs to be triggered at the widgets endpoint. And if the incoming message is gadget, we need to be our gadgets endpoint needs to be called. And if there is no condition that matches the current event, we just have to be called at products, or rather our application. So this is the way to do it in a programmatic way. The other way is to have a subscription in YAML, which is, I think, really the better of both, because it really doesn't have anything to do with your code. And if you want to change the route for some reason, you can do so by changing the configuration and redeploying it, but you don't have to change the code. Well, obviously, if you want to introduce another method here, it will be kind of tricky. So that's the declarative subscription. Let's see what the application happens to do. So here is the products endpoint, which is the one called by default. And this is that weird emoji that basically says that, hey, I don't know what to do with that product. And it just repeats the result. But if we have a widget, it will display something like a widget, and it will return the body. If it's a gadget, it will display a gadget with some icons. But since this relies on cloud events, we have an action method here or an endpoint that is exposed. And we are going to use that endpoint for publishing events into Dapr. So it just wraps the request into what's expected for cloud events, and it will help in a way. So that's about our application. Let's go and see it in action. So of course, because we're running that locally, you have to do npm install at first, but I have done that already. And here we specify that the configuration of Dapr is this file, the application app ID is pub/sub routing, and the components that we want to use are stored in that folder here on the left side. And the application port is app port 3000. And the way that we start a new Node application is basically Node in the application entry file. So the application seems to be running. Now let's use curl to invoke the publish method. And here we're going to start with the widget format, with the widget payload. So the type here is widget. So we expect to see the widget icon. Okay, let's see. So it said that the message got accepted. Let's see in the terminal where Dapr runs how things are going to look. So this is a widget. I don't happen to see the icon, but that's weird. I want that icon to. Here it is. So at first, it just returns the whole body, and then it returns the icon in the respective endpoint. So that's the widget icon. Let's see the gadget icon. Gadget is this. So each of those messages is correctly, basically correctly routed to the specific endpoint that we expected to go to. And think a magic. Let's see how think a magic looks like. And that's that weird icon that figures out, wonders what you're doing with your application. Anyway, that was all about the demo in the publish and subscribe building block. I hope it is now more clear than before for you. So we have another building block called input bindings. And for that, I don't really have a demo, but that block allows you to basically integrate with external systems, like, for example, Twitter. So whenever a new tweet comes in, your application can be triggered by Twitter, and it has an endpoint to handle that result, to handle that payload coming from Twitter. And Dapr will do everything that is needed in order to subscribe to Twitter. So that's pretty handy if you want to integrate with an external system. And it's kind of the serverless programming model applied here in this building block, because you just specify the Twitter configuration like this. You say the consumer key is stored here in the secret key reference, the consumer key, and any other thing that the Twitter component expects. And basically, Dapr will invoke that application. Here we can see the sidecar to application, because the sidecar is the thing that is going to invoke your application. Whereas we have a different direction of bindings, which are output bindings. And that's when we want our application to store something or to integrate with another service. But here the color is our application. That's why it's called output binding. And for example, if we use Twilio for sending messages, we just call our Dapr API, and the component of Twilio happens to be named Twilio, and then we send the payload that's sent message. Not really original, but it works. So when it comes to secrets, you know that the organizations have a variety of restrictions where you can store secrets, how you can store them, what are the processes when it comes to rotating those secrets. And this is the way to obtain secrets from your end secret store by using Dapr. You just call secret/vault/ the secret name, and it returns the secret name. It's a GET request. And by the way, the secret API is only for retrieving secrets. So if you want to persist those secrets, you cannot use Dapr, because when it comes to secrets, it just stays on the consumer side of things. So you have to figure out another way to store your secrets, really. And you can retrieve them one by one, or you can retrieve them in bulk. And on the left-hand side, you can see the YAML definition of the secret store component for HashiCorp Vault. And here you can see the vault address, the port, and the certificates that needs to be used. And that's pretty much it for secrets. Now let's see virtual actors. Now virtual actors is a pretty popular programming model for IoT use cases or for gaming scenarios. But you can really use it wherever you like. So this virtual actor model is pretty opinionated. You have to strictly follow basically the core ideas, and everything basically is an actor. It lives somewhere, and it has some methods that it can perform. Like from example, this is an example from a video game, but I know that Microsoft, among their first attempts, was to introduce the virtual actor pattern in Hello. So this is again a similar video game actor enemy. So the enemy is represented by actor that has the spawn and the attack methods. It has properties for X, Y, and Z positioning. It also has properties for difficulty and weapons. So it's kind of OOP, but object-oriented programming, but hosted somewhere on a host or on a pod. So Dapr takes care of the distribution and failover. So whenever an instance of that enemy has to be instantiated in memory, Dapr will make sure to place that actor somewhere, and it will basically persist the position somewhere. So the Dapr virtual actors also feature what's called a turn-based concurrency. So if you have an actor, just one operation can be happening at a time, and it really becomes very interesting when you have an actor calling another actor, calling the first actor in the code chain, but you now have ways to control that. And actors obviously have state, right? So this difficulty and weapons are kind of properties of the actor, so it has to be stored somewhere. But since Dapr features a state store building block, it just uses it for virtual actors, right? And actors can execute something on a period of time, like a timer or reminder. And here you can see the example where we have two hosts that are hosting a different actor objects, actor instances. And something happens with that first host, and Dapr is pretty intelligent so that it can make sure that all those instances that used to be live in the first host that is now dead are transferred to the live host that is still operable and working. And the virtual actors are basically identical to the implementation in Service Fabric. So if you have used reliable actors in Service Fabric, you will see a lot of similarities. The .NET SDK for Dapr, when it comes to virtual actor, is pretty close, if not the same. So how the virtual actors work? How do they work? So we have an application that wants to use a virtual actor, and we have a couple of actor instances that are distributed across two actor hosts, which at the moment are pods, but it doesn't really matter. And basically, your application calls the method update of my actor. That's the type of the actor, and A is really the instance of that actor. So we want to update we want to call the update method of that actor, and we want to pass speed equals to 1. So Dapr will interrogate the placement service, which is a built-in component of Dapr. So in order to work Dapr, and in order for you to use virtual actors, Dapr needs to have the placement service installed and running properly somewhere. So this placement service will figure out what is the location and where that actor is hosted. And once that is done, the Sidecar system will invoke that actor. So that was all about actors. We don't have a demo for them, although that's an interesting thing. Let's see the configuration building block, which is, I think, if I'm not mistaken, the last building block that was introduced to the collection of building blocks. And that is for storing configuration items of your application. So each and every application has some configuration properties that usually come from some environment. But if you want to make them come from an external service like Redis Cache, you can utilize that configuration building block. And during the start of your application, you can just make a couple of calls to Dapr and basically cache those values somewhere. So in this way, your application will be will get provided with the values that it depends on a startup time. So a couple of words on observability. The fact that Dapr features this sidecar model, the sidecar rather design pattern, makes it very easy for you to have observability on the runtime level, because each and every communication with Dapr and respectively with all applications and external services is going through the system of sidecars. So it's very easy for you to configure the open telemetry collector that is going to collect all those logging and tracing information that you can then you can route them to or direct them to an observability system of your choice, like Application Insights, or if you prefer to use Zipkin or Jaeger or Prometheus, you can all use them with that telemetry collector. And when it comes to distributed tracing, it's very beneficial for you to know what is happening inside your microservices application, because the microservices architecture is kind of complex. It features a lot of services, a lot of instances. So with observability, you get a graphical way of representing the call graphs that uses internally trace IDs and trace scopes. And you can capture call metrics and see how your entire system behaves. So on the right-hand side, you can see the Zipkin interface. And besides, next to Zipkin, there is I think that's Application Insights, the UI of it. For metrics, you just need to know what is happening with your systems at the time. So what is the CPU usage? is everything healthy? And Dapr really exposes a set of metrics that you can configure in your Grafana dashboards, so that you can monitor things like system health or the sidecar injection failures, if there are any, or any other error rates. And at last, I would like to spend a couple of minutes to talk about resiliency, because here we depend on Dapr to be our kind of a butler and to do the work for us, and to call other applications and to integrate with external services. But really, not everything is nearly as available as we would want it to be, because things in the cloud, they have throttling. It's part of the design of the cloud. You just cannot consume the whole limit of the service that you have paid for, or even beyond that. So occasionally the things will fail, things will slow down, and you will have to prepare for that. So the resiliency function was a very long-awaited feature, because it's pretty important. Errors can happen at pretty much every point of that architecture. So now with the resiliency policies and the resiliency pattern in Dapr, we can control that. And we can control that in three major ways. We have retries. So if anything fails, we can retry. The retry, as you can see on the right-hand side, here the retry is just 5 seconds, but it can, sorry, that's the timeout. The retry is with a duration 5 seconds, and you can retry at max 5 times. So we can control that. You can also specify some backup rules if you want to not to provide constants here. For timeouts, you just specify a timeout with its name, which is called general, and we set the timeout limit to be 5 seconds. But if you want to specify another type of timeout, we can just make another line here and call it very important timeout, and put a timeout like 1 hour, because it's very important. We have to wait for it, right? So this is really a collection of timeouts that you can then reference. So you can reference those policies in your targets, and that's the target section of the YAML. So you can specify for each and every app what kind of timeout to use. It happens to be the general timeout here. The retry policy is called 5 retries, which is from here. And the circuit breaker is simple CB, which is configured here. And the resiliency functionality is really available for all component types, across service invocation building block and across the actors building block. We'll see. So the service invocation used to be just the built-in service invocation between sidecars, which happens with a backup interval of 1 second up to a threshold of 3 times. But now we can additionally control that with the retries and the timeouts and the circuit breakers policies. So we need resiliency also on the outbound side. So if you're calling some component, we can control the resilience. Like for example, here the Redis state store is our component that will persist our state. So we want to control the policies of the outbound calls from the Dapr sidecar system to Redis, for example. We have inbound components, which are whenever something calls into Dapr. This is basically, well, not inbound. Well, no, that's wrong. So we have the input binding that is for example, cron input binding, and it has to call your application. So your application considers that to be an inbound call, so it's coming from the sidecar, and you can control that with the policies. You also have a resiliency options to control in the pub/sub building block, and that happens to be on both sides, on the outbound and on the inbound. And let's see the Dapr hosting environments. So there are three major ways to host Dapr. First is self-hosted, the thing that we saw on the first and the second demo today. So you have to call Dapr init. It's a good idea to have Docker, but it's nowhere near a requirement because there is a slim init mode for Dapr. You just have to take care of the other additional services like the actors placement service and the Zipkin container and the Redis one. So if you don't use Docker, you have to figure out how to stand up those on your own. But really, the best development experience, in my opinion locally is to use Docker. Then on the right-hand side, we have Kubernetes, which is basically the preferred way of running Dapr in production. You get started with it by calling Dapr init-k, and you receive the Dapr control plane for you. It's automatically deployed by the CLI, and it has the placement service, the operator, and the sentry. Sorry. And we also have a virtual machines mode, but here it is kind of more difficult to configure. You have to use HashiCorp console per machine, and I really intend maybe next week to publish an article on or a blog post on my blog for that, because it's really interesting for me and I haven't tried it, and I may learn a thing or two to share. So let me know if that's something that you are interested in. So here is the visual description of Dapr in self-hosted Docker mode. You can see the three containers, and obviously you can run that across a variety of operating systems. And the variety of components, they are all supported in all modes. You have the Dapr in self-hosted mode on VMs. Here is the console agent, and we have the actor placement service and the cert authority, which are well, they have to be started additionally. But I really hope to shed some light on that with a blog post. And Dapr on Kubernetes, everything is a pod, right? So the Dapr system comes, and you can see it on the top of the screen. So the operator is the guy who usually deploys your Dapr applications into Kubernetes. And here is your app talking to all those system pods. And the kubelet of Kubernetes basically monitors the state of your and again the components, and you can run that on any Kubernetes platform of your choice. So it's time for questions, guys. Do we have any questions?
Okay, so Radoslav, you're through with slides and demo, I see. Well, I checked the chat. So far, I don't see any questions appearing. Maybe give some moments time if someone at the end wants to raise a question.
Yeah, if you have any questions, now is the time to ask it. Meanwhile, I will stop sharing my screen.
Yes. Okay. So, but besides, so thank you very much, Radoslav, for being a guest speaker at our meetup, for giving a long and great session with many insights from all these Dapr topics, with these broad options you have, and then integration. And I think, I mean, if you want to make something like a final summarize, but I think really regarding these distributed microservice-based applications, it's really a great help. And on different deployment hosting options, you mentioned really a lot of topics. So I think great insights, and yes.
Yeah, so the distributed applications are kind of tricky to be built, and you better choose the proper runtime or framework or whatever you are going to use, because at some point you may want to scale out or change a little bit the architecture, and it may turn out that you have to basically rework everything and start from scratch, which is not really a pleasant experience. And really, if your application is not distributed from the get-go, you can still use Dapr. It doesn't require you to use every building block. You can just start with, let's say, service invocation, and you can go with it until you see a use case for like introducing a newer service or a couple of them. So it's really a non-prescriptive way to build distributed applications.
Yeah, great. Thank you for also last summarize.
Since we don't have any questions, feel free to ask them either over LinkedIn or Twitter, or wherever you find me online. I'm here to answer, no problem. And
sure.
Thomas, thank you for having me. It was a pleasure to speak in this Zurich user group for Azure. I hope next time we make something in person.
In person,
as I said, I would love to visit Switzerland.
Yeah, it would be fine. I think we are all a little bit müde is the word. I'm tired regarding all these virtual stuff and sessions just online. I mean, at the end, it's an option to have it globally accessible, but yeah, heading forward to meet the persons again. So no questions so far. Then I would end the live session and say last time, thank you very much for listening, and have a nice evening, and goodbye. Ciao, ciao.
Have a nice evening. Bye.